Welcome back. Here we go. Differentiation of discrete functions. Discrete function. So discrete function is when the function will be given to you on what? A table form. But remember this. That the first derivative is what a function, let's say f of x. The first derivative is what? Is the same as what? The velocity. The velocity. And the second derivative is the what? The acceleration. The acceleration. So the velocity can be in terms of what? X. Alright. So now, looking at this question, the upward velocity of a rocket is given as a function of time. So that means that the upward velocity, that is the second what? Derivative. Oh, sorry, the first derivative, and then the second derivative of time in the table below. Alright, so that's the table. That means that this table, that function that they use to compute to get this table, is the first what? Derivative, which is the velocity. So now you are to find the acceleration. So remember that the acceleration is the second what? Derivative. So now the question says find the acceleration of the rocket at t is equal to 16 seconds. 16 seconds. Using the forward divided what? Difference. Using the forward divided what? Difference. Let me start from where you know. You know that the forward divided difference is in the form f prime, right? Which will be equal to, that is f of si plus 1 minus f si, all these divided by delta of x. But please, in dealing with this question, you want to read it carefully and know that the velocity we have is the first what? Derivative. So if you write this formula down, you are wrong. The formula we have to use to do this is supposed to be f prime of this, which is equal to f prime of that minus f prime of this, all this over delta x. The reason is that the upward velocity of a rocket is given as a function of time in the table below. So the velocity is the first what? Derivative, and that is what that function, that slope function or that derivative function is what they use to compute to get this table. So that is that. How you can see that? Alright, it can be that you're not seeing what I'm talking about. You let's continue, you will have it. Alright, so now, even what we are to find is what? Acceleration. So the acceleration, the f we are using here, we have to change it because we know that the second derivative will be the acceleration. So a in terms of what? T, because that is what? Time. So t will be equal to, then the f prime here will be the first what? Derivative. I love it. So that will be v. Then here will be ci plus 1 minus v ci. Alright? All these over delta t. So this is supposed to be the formula to use. So we have to understand the FDD, the BDD, and the CDD that we normally use to solve questions. Alright, so getting this, then the question becomes easy. Alright, so let me clean it, then we move on. Okay. So now, we have established that the formula we are using to do the LDD for the I is equal all these over delta t. Alright, so from what we have, let's always start the initial will be given to you. So what we have, the time that we have in the question is 16 what seconds. So we know our Ti supposed to be 16 what seconds. But you see, in this case, we don't have the function. We don't have the function to go and do the substitution, right? Oh, sorry, no, not the Ti. It's not the Ti. All right, it's not the Ti. So the T is equal to 16 seconds. That's what is given to us. But in this case, so that's the T. But in this case, we don't have the velocity function to go and do the substitution. It's given to us in the table form. And in the case that we don't have 16 in here, so what will we do? So this is what we are going to do. Because we have to identify so the first thing to identify is to know this. The second thing to identify is to know T of I. And the second thing to find is Ti plus 1. This is the initial and this is the final. And the next thing to know is delta T. Alright, it's just simple. Let's continue. Alright, so now the time given you is 16. So you come to the table. Then at the T, check where the 16 will be falling. You see that the 16 can fall between a certain value. You can also get it at that exact value too. But when you check, you can see that 16 cannot fall between here and here. It cannot fall between here and here. And it cannot fall between here and here. So the only option is that we have 10 here, we have 15 here. 16 cannot fall here. So we have 15 here and we have 20 here. Then wow, we can see that within this, we can get this 16. So that means that our initial will be 15. And the final will be 20. Therefore, I hope it's clear. The 16 is within 15 and what? 20. Then we can pick the initial to be this and the final to be this. Therefore, we can find our delta what? T. That is the change in the what? In the time. And that is going to be Ti plus 1 minus the Ti. So that's going to be 20 minus what? The 15, which is 5. Alright! After getting this done, we are almost done with the question. So let's see. So after getting this, please I'm cleaning it too. Alright? So now, we know that our delta T is 5, our Ti is 15, our Ti plus 1 is 20. Alright, that's what we need. And our T is 16. That's what is given in the question. So we start. A of 16 will be equal to, that place is what? 20 minus, that will be 15. All these over delta what? T. And that is delta T. That is 5. Alright, so here, this is what you are going to do. It's just simple. You know that the velocity function is what was used to compute this table. So this one, the work has been reduced. Yeah, sure. So you go and check. When you plug in 20 into the function, when you plug in 20 into the function, what will you get? That is that. You get 517.35 minus, when you plug in 15, what will you get? 362.78. Alright! All this over 5. And then the rest is calculator. And finally, you are going to get 30.9 1.14 meter per second square. Don't forget, because it's what? Acceleration. So that will be meter per second what? Square. That's all. You know that. You see how nice it is? So can you continue with the backward divided difference? Do it and I'll be back with the solution. Alright, welcome back. So the BDD, that's going to be the solution. I hope you have it. Thank you. See you for your second question. Bye bye. Love you.